This question is asking determine C transform and the ROC of the following signal. And here we have the signal provided x of n is equal to 1, 2, 3, 4, 5. And we have the arrow at 1, which means this is at the origin. This is at the 0. Now, whenever we have a signal and if you want to find out the C transform of this, we have to use this equation, which is x of z, that is equal to summation of n is equal to negative infinity to positive infinity, x of n z power minus n. Here the x of n is nothing but it's going to be the amplitude, and that is whatever the number we have here. Okay, and z power minus n, this minus n is wherever the location of the certain points. So for the one, this is located at 0. This is going to be c power 0 for that, and like that we have to follow for everything. Okay, now let's go ahead and do one by one. So here what we have to do is, even though the limit is negative infinity to infinity, we have to just look at wherever we have something available. Here in this case it starts from 0, then this is 1, 2, 3, 4, then we only gonna have 0 to 4. That's gonna be our summation location, but it's not necessary to include, but you can just express like this: n is equal to 0 and it goes up to 4. Okay, and that's gonna be our region x of n z power minus n. Now we can go ahead, we have to just sum them all together, and also we have to put the z power whatever the location it's there. So here first of all x of n, which is x of, if we start from x of 0, at x of 0 we have 1, so I just put the 1 here, and then z power 0, that is also 1, so I don't have to put that one there. And then if I look at 2, that's the amplitude x of n, and then z power, this is at location 1, so z power minus 1. And then if I look at this one 3, this is z power minus 2, and then 4 z power minus 3, and then 5 z power minus 4. Okay, this is our C transform. Now once we get the C transform, the next thing is we have to find out whether the region of convergence. To find out the region of convergence, better to express this C transform in a better way. So I copy this one and bring it to the next page. Rearrange this one in a better way. Okay, now instead of 2 power z minus 1, I'm going to just put the c in the denominator. So this is going to be x of z, which is equal to 1 plus 2 over z plus 3 over z square, and then plus 4 over z cube, and then 5 over z power 4. And whenever we are dealing with a signal like this, we have to just apply 0 and infinity, because those are the only crucial point. We have to see what's happening to the region of convergence. So first, if I apply infinity, or we can start with a 0. If I start with 0, if I apply 0 for the z's, what will happen? As you can see, if you divide any number by 0, that's going to be infinity. So we are going to have 1 plus infinity plus infinity plus infinity and infinity, and that's going to be, the answer is going to be infinity. But region of convergence cannot be infinity, it should be a finite number. So at 0, the region of convergence doesn't exist. So that's what we can conclude. And then we have to check for the infinity as well. We have to see at z is equal to infinity what will happen. Similarly, if you look at this one, if I divide any number by infinity, that's going to be 0. So except this 1, everything else is going to be 0. So 1 plus 0 plus 0 plus 0 plus 0, that is equal to 1, but it is giving a finite value. So region of convergence at infinity exists. So we can say the ROC of x of c is available over the entire region of C plane except z is equal to 0. The last part is important. We have to say that except z is equal to 0, because at c is equal to 0, we don't have a finite value. Okay, let's go ahead and write that one down. So the ROC of x of c is available over the entire region of C plane except c is equal to 0. Okay, and that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.